All right, let's jump right in. Today we're tackling something huge, the Open Network, or TON. We're going to go back to its foundational white paper to really get our heads around its goal, which was, well, nothing short of building a whole new internet. We're talking fast, decentralized, and for everybody.
So, right from the get-go, the vision was massive. The white paper doesn't just talk about another cryptocurrency. No, it paints a picture of TON as this giant, distributed supercomputer. Think about that for a second. A single global computer meant to host and run all kinds of services for anyone, anywhere.
But, that immediately brings up a huge question, right? I mean, how on earth do you build something that big, an internet-sized computer, on a blockchain? That's the real challenge. It's a massive technical problem. So how did they even plan to pull it off?
Okay, so let's get into it. We're going to deconstruct this grand vision and see exactly how the open network was designed to be fast, secure, and scalable enough to handle, get this, potentially millions of transactions per second.
Right. First things first. To really get TCON, you have to realize it's not just one thing. It's more like a whole platform, an ecosystem of different building blocks. And they're all designed to fit together perfectly to create this new digital universe.
And at the very heart of this whole thing, you've got the TON blockchain. Think of it like the central nervous system. It's the core, the absolute backbone that coordinates everything. It's what's processing all the transactions and running the smart contracts. You know, those little if this then that programs that make the whole network go.
So if the blockchain is the brain, then TON storage is kind of like the network's global hard drive. It's a totally decentralized way to store files, a bit like how torrents work. This is where everything gets kept, from old blockchain records to the files for the apps that are actually running on TON.
Okay, but all this tech is useless if it's impossible to use, right? That's where TON DNS comes in. It's basically the internet's address book for the network. It takes those long, complicated wallet addresses and turns them into simple names that people can actually remember and use, just like you type in a website name instead of that string of numbers.
And last but not least, for this supercomputer to actually be useful, you've got to have a way to pay for services on it. That's what TON Payments is for. It's like a high-speed express lane for money. It's built for super fast, tiny payments that happen off-chain, which really just means they happen outside the main blockchain to keep things instant and really, really cheap.
All right, so we've got the main parts of our supercomputer. But the real magic, the secret sauce that makes this whole thing theoretically able to scale to infinity, is all in how the core blockchain is built. This is where TON's approach gets really unique.
And this really hits the nail on the head. Think about a regular blockchain. It's like a single-lane highway. Eventually, you're going to get a traffic jam. It just gets clogged. TON's approach is completely different. It's more like a smart network of highways that can literally build new lanes on the fly whenever traffic starts to pick up. So how does this highway network actually work? Well, it's a three-layer system. At the very top, you have the master chain. That's the main rulebook, the constitution for the whole network. Then under that, you can have work chains, and we're talking billions of them, each with its own custom rules. And then each one of those can be broken down even further into shard chains, which is where the real work happens. And here's the really cool part. This whole system is alive. It's not set in stone. These shard chains are dynamic. If one of them starts getting overloaded with transactions, it just automatically splits into two new chains to share the work. And when things quiet down, they can merge back together. It's constantly adapting. The white paper actually gives this a name, the infinite sharding paradigm, and it's what they call a bottom-up approach. See, instead of starting with one giant blockchain and trying to figure out how to cut it into pieces, TON's design starts from the other end. It imagines that every single account has its own tiny little blockchain, and then it figures out the most efficient way to group them together. This was a totally different way of thinking about scale at the time.
Okay, a supercomputer that can scale to the moon is an amazing idea, but it's totally worthless if it's not secure, right? So, who actually runs this thing? Who are the guardians making sure everything is safe and sound?
The whole network is secured using what's called proof of stake. So forget about miners solving crazy math problems. Here you have validators who have to put up a big chunk of their own money, a stake, to participate. That stake is basically collateral. If they play by the rules and validate transactions honestly, they get rewarded. But if they try to cheat the system, poof, they can lose their entire stake. It's all about having skin in the game.
And this setup creates this whole little economy of different players, all with a job to do. You've got the main validators who are creating and checking the blocks. Then you have nominators, who are like financial backers, lending their funds to validators to earn a cut. You even have fishermen, whose entire job is to watch for bad behavior and report it, and collators who help get all the data ready. It's a whole system of checks and balances where everyone is motivated by money to keep the network healthy.
All right, we've gone through the different parts, the secret to its scaling, and how it's all kept secure. So let's zoom out for a second and pull together the big takeaways from this whole thing.
So what are the big ideas to remember? First, TON isn't just a blockchain for payments. It's a complete ecosystem with storage, DNS, the whole shebang. Second, it's built for scale. That infinite sharding paradigm is designed to grow forever with demand. Third, it's secured by people with skin in the game through that proof-of-stake model. And finally, all these moving parts can talk to each other super fast, which is absolutely crucial if you want to run really complex, high-performance apps.
And that really brings us to the final big question. What we've just walked through is a blueprint, a design that was created to smash through the speed limits that have held blockchains back for so long. So just think about it. If a blockchain could really handle millions of transactions a second, what becomes possible? What kind of new apps could we see? Things we couldn't even dream of before, like a truly decentralized social network, or maybe even super fast financial trading systems that run completely on a blockchain. What does that future look like?